So in this video, we're going to work on the problems that are in the Unit 3 test review. So let's try simplifying this radical right here. So you can see we have a cube root. So we're going to separate this out. So we have the cube root of 64, then the cube root of x to the 18, and the cube root of y to the 30. So remember, we want to look at 64. And if we look at our study guide, you can see that the cube root of 64 is actually equal to 4. So that will just simplify to 4. So now remember, with the exponents on the variables, we want to see if they're divisible by that index. So 18 is divisible by 3, so that's just going to turn into x to the 6th. And then 30 is divisible by 3, so that's going to turn into y to the 10th. So this whole thing will actually simplify to 4x to the 6th, y to the 10th. So now let's try simplifying this radical. So you can see we have a square root. So let's go ahead and separate everything out. So we have 5 times the square root of 72, and then the square root of x to the 11th, and then the square root of y to the 24th. So from the square root of 72, we want to factor out the biggest perfect square we possibly can. And so if we look at our chart of square roots, you can see the biggest perfect square that will evenly divide 72 is going to be 36. So we're going to rewrite this as the square root of 36 times the square root of 2. And then from the x to the 11th, we want to rewrite it so that we have the biggest exponent less than 11 that's divisible by 2, right? Because remember, for a square root, the index is actually 2. So the biggest number less than 11 that's divisible by 2 is going to be x to the 10, right? So we can rewrite this as x to the 10 times x to the 1, because remember, our exponents just have to add to equal 11. Y to the 24th, well, 24 is divisible by 2. So we can just go ahead and divide that exponent by 2, so we have y to the 12th. So now let's go ahead and simplify. So we have 5. The square root of 36 is going to become 6. Then we have the square root of 2. X to the 10th, remember, we can just take half of that exponent. It's divisible by 2, so that's going to become x to the 5th. The square root of x is just going to stay like that because it's can't be simplified. And then we have y to the 12th. Now let's go ahead and collect everything we have on the outside. So we have 5 times 6, so that's 30. Okay, then we have x to the 5th, and we also have y to the 12th. Okay, everything that stays under the square root, we're going to leave there. So all we have left under the square root is this 2 and x. So we have the square root of 2x. So this whole thing will simplify to 30, x to the 5th, y to the 12th, and then the square root of 2x. Let's work on this problem. So here I have a fourth root. So I'm going to go back to my nth roots chart. And you see that we need to separate this out, right? So we're going to separate this as the fourth root of 625, and then the fourth root of x to the 20th, and then the fourth root of y to the 16th. Okay, so the fourth root of 625, notice on my chart, that is actually a root. So the fourth root of 625 is going to become 5. And then with the x to the 20th, I want to see, is 20 divisible by 4? It is, so that's just going to do 20 divided by 4, so that's going to become x to the 5th. 16, is 16 divisible by 4? Yeah, it is, so that's just going to become y to the 4th. So this whole thing will simplify to 5x to the 5th, y to the 4th. So now here we have a square root equation, right? So here we have a square root equation that's asking us to solve for x. So let's go ahead now and work on doing that. So remember, the first thing is to isolate the radical, but my radical is already isolated. So I'm just going to go ahead and square both sides, right? Because remember, that's how I undo that square root. So I square both sides, and then I get x minus 2 equals 7 squared. So if I want to do 7 squared, I can just use my calculator. 7 squared is 49, so I have x minus 2 equals 49. Now to solve for x, I need to do the opposite, and I need to add 2 to both sides. When I add 2 to both sides, I get x equals 51. So 51 is the solution. Remember, you want to always check your solutions and make sure that it makes your equation true. So the square root of 51 minus 2, is that equal to 7? Well, that's telling me the square root of 49 is equal to 7, so that is in fact true. So here we have another square root equation. So once again, you can see I need to isolate my square root, right? My square root is not by itself. It has that 6 with it. That 6 is a positive 6, so I need to do the opposite, and I need to subtract 6 from both sides. When I subtract 6 from both sides, I get the square root of 2x minus 3 is equal to 21 minus 6, which is 15. So now that I have the square root isolated, I need to go ahead and actually square both sides. So when I square both sides, on the right side, I'm going to do 15 squared. So I can use my calculator for that. So 15 squared is 225. So I have 2x minus 3, because on the left side, when I square it, I get rid of the square root sign, and then that's equal to 225. Now what I need to do to solve is I need to go ahead and add 3 to both sides. When I add 3 to both sides, I get 2x is equal to 225 plus 3, which is 228. Now to solve for x, I'm going to divide both sides by 2. So that's going to give me x equals 114. So remember, on square root equations, you always want to go back and plug in and make sure it makes your equation valid. So we have 2 times 114 minus 3 under the square root. So we have 6 plus the square root of 228 minus 3. And that's telling us that 6 plus the square root of 225 is equal to 221. So 6 plus, and then if I want to do the square root of 225, I can just use my calculator. So the square root of 225 is equal to 15. So 6 plus 15 is equal to 21 is true. So that makes my solution valid. Okay, so here's another problem where it wants us to solve for x. So here my square root is already isolated, so I'm going to go ahead and just start off by squaring both sides. Okay, so it's very important to remember that on the right side when you're squaring it as a binomial. Okay, so that whole thing is getting squared. We don't just do x squared plus 2 squared because that's not how you square something that is being added together. You have to square it as though it's a binomial. So that means I'm going to have 2x plus 3 equals, and then that x plus 2 squared, I'm going to actually use one of my polynomial methods for that, right? So you can do x plus 2 squared is x plus 2 times x plus 2, or you can use special patterns. So if you do FOIL, okay, remember first times first is x squared. Outside x times 2 is going to be 2x. Inside 2 times x is going to be 2x. And then last times last, 2 times 2 is 4. If I add up all my terms, I get x squared plus 2x plus 2x plus 4. If I combine those middle terms, that gives me x squared plus 4x plus 4. So I'm going to go ahead and write that on the right side of my equation. So I have x squared plus 4x plus 4. So notice now you have a quadratic equation, right? Because we have a square term. So we need to go ahead and set this equation equal to 0, just like we were doing in the quadratics unit. So I'm going to subtract 2x and subtract 3 from both sides in order to do that. So I'm going to subtract 2x and subtract 3. And so that's going to give me 0 equals x squared plus 4x minus 2x is 2x. 4 minus 3 is going to give me plus 1. Okay, so you can solve this several different ways. I know some of you like to graph, some of you like quadratic formula. I'm actually going to factor this. So I actually need two factors that are going to multiply to 1, but then add up to 2. Well, the only factors of 1 are 1 and 1. They need to both be positive because they're going to add up to 2. So this factors into x plus 1 times x plus 1. Okay, x plus 1 times x plus 1 is basically x plus 1 squared. So if I set this factor equal to 0, so if I say x plus 1 equals 0, I'm just going to get one solution, right? If I subtract 1 from both sides, that gives me one solution, which is x equals -1, since I have that repeated factor. Remember, you always want to double check and make sure that you don't have an extraneous solution. So I'm going to plug it back in. So square root of 2 times -1 plus 3, is that equal to -1 plus 2? So that tells me that the square root of -2 plus 3 is equal to 1, which is telling me the square root of 1 is 1, which is in fact true. Okay, so now let's try this equation. Here we have a cube root equation, okay? So the opposite, remember, of a radical is to do the power of the index, okay? So what I'm going to do is I'm going to raise both sides to the third power, and that's how I'm going to undo that radical. So when I do that on the left side, I'm left with just 5x plus 1. And then on the right side, I have 6 cubed, okay? So I can just do 6 and then exponent 3, and that tells me the value, which is 216. Okay, so now I need to solve for x. So I'm going to subtract 1 from both sides. So when I subtract 1 from both sides, I get 5x equals 215. Now to solve for x, I need to divide both sides by 5. So I'm going to go ahead and I'm going to do that on my calculator. 215 divided by 5, and that's equal to 43. So I have x equals 43. Okay, and that's my solution. All right, so here we have another cube root equation. So we have the cube root of 8x plus 3 equals -5. Once again, remember, I raise it to the power that's equal to the index, which is 3, in order to get rid of that cube root. So that's going to give me 8x plus 3 equals, and then if I want to do -5 to the third, I can do that on my calculator. I do -5 to the third power, and you can see that's -125. So I have -125 on the right side. Now to solve for x, I just need to go ahead and subtract 3 from both sides. When I subtract 3 from both sides, I get 8x equals -128. Now I need to divide both sides by 8. And I can do -128. Oops, -128 divided by 8, and that gives me negative 16. So x is equal to negative 16. All right, so now here we have another cube root equation. So let's go ahead and solve for x. The difference here is that the radical is not already isolated. Okay, so remember, if the radical is not already isolated, we need to do some extra work to go ahead and isolate it first. So I'm going to start off by subtracting 5 because that 5 is the adding and subtracting step. So remember, we do the opposite of order of operations. We do the add or subtract before we do the multiply or divide when we're solving. So that's going to leave me with 2 times the cube root of x minus 2. And then we have 21 minus 5, which is 16. My cube root's still not isolated, so I'm going to go ahead and divide both sides by 2. So when I do that, I get the cube root of x minus 2 is equal to 16 divided by 2, which is 8. Now that the cube root is isolated, I can go ahead and raise everything to the power equal to the index. So I'm going to raise both sides to the third power. So we have x minus 2 is equal to, and then here I'm going to do the exponent, 8 to the third, and that gives me 512. So we have x minus 2 equals 512. Now I can solve for x by adding 2 to both sides. So that's going to give me x equals 514. And that is my solution. So now in this last problem, it wants us to simplify. So it asks us to simplify and it's giving us a cube root. So I'm going to start off by separating everything. So the cube root of 125, the cube root of x to the ninth, and the cube root of y to the 13th. So now let's go back to our chart and see what we can do with that 125. So notice that 125, the cube root of 125 is 5. So I'm just going to turn that into 5. If we look at this exponent on x, 9 is divisible by 3. So I'm just going to do 9 divided by 3. And that's going to give me x cubed. Now I need to look at the y to the 13th. 13 is not divisible by 3, so I need to rewrite it. The biggest number less than 13 that's divisible by 3 is 12. So I can rewrite this as y to the 12th and then the cube root of y. Okay. So now I have 5x cubed. The cube root of y to the 12th will simplify to y to the 4th. And then we have the cube root of y. So this is now the fully simplified form of this radical.